The sun's zenith positions, measured as 23.5 degrees north and south on the flat Earth map, are indisputable observational facts. When the flat Earth map was projected onto a sphere, cartographers faced a challenge: how to account for the sun's declination without losing the integrity of the sun's path. To solve this, they introduced a 23.5-degree tilt to the globe model, aligning it perfectly with the sun's observed GP over the flat Earth. This tilt was not a physical necessity, but a mathematical one, fabricated to preserve the flat Earth's sun path in the context of a globe.
Negative means the south. This would be page 19 of the Flat Earth Science textbook if you have it and want to go into detail. But it's important to understand that these positions we're not making up. It's called the ground position. So you can pause the video, go on Google, search what is the ground position. This is an undeniable reality. So we're not making up the path that the sun takes. We know the path that the sun takes. Over a period of 24 hours, it completes that rotation. And the declination, a celestial declination, means it's traveling in and out. This is the sun's analemma. So actually, I just want to open this just so you know what I'm talking about. You will see the sun's analemma on page 19. This is where we get into a lot of the advanced stuff. This is still beginner stuff, but when I say advanced, I'm talking about diagrams, quantifying it, explaining why. I don't just want to tell you this is the path that the sun takes, because someone will say, no, it's not, you're just making it up. I need you to know why it's an undeniable reality that the sun takes this path. We find that when cartographers and scientists wanted to convert the flat Earth map into a globe, they encountered a fundamental problem. The sun's path of 23.5 degrees. How do you account for that on a globe? We know that the 23.5 degrees already exists in real life. Therefore, they had to account for that. And what they did is they made that tilt. That is why it's tilted. So this is how it would be normally if you have, let's say, a spherical geocentric world, which many people do believe in, but I'm teaching you flat geocentric cosmology. But I want you to know how extreme the heliocentric argument's taking it. So then they tilt it. We're on a tilt now because you have to compensate for that because Earth is no longer the center. That's actually, I guess, the main problem. It's not just a globe. It's what they did with their cosmology. So they took the sun, they placed it way up there, they have everything rotating around like crazy. So to do that, you have to tilt Earth. Earth is now tilted 23.5 degrees. And you have to, because you're trying to compensate for what actually happens in real life. If we know that in real life the sun will be traveling between these two paths, you'd have to tilt it like that. So let's say the sun only traveled to a declination of negative 21 degrees and a positive declination of 21 degrees. Well, if I want to be a pseudoscientist back in the day and discover the globe, my tilt would need to be 21 degrees instead of 23.5. Does that make sense? Because we're matching what the flat Earth model does. That's how you reverse engineer and create something deceptive. So what's important to understand is that the 23.5 degree axial tilt coincidentally aligns with the sun's declination. It wasn't derived from physical evidence. You can't actually go into space and look at a globe spinning and tilting. It's a conceptual model, and it has to be based on the flat Earth. And that's where you get the 23.5 degree tilt. The large Gleason map that you see here is canvas print. So it's not just a sheet of paper. We sell it for 25 USD, the exact same thing that Amazon sells for 35. Check it. It's going to be 90 centimeters by 60 centimeters across canvas print Gleason map. So because I have access to supply chains and I built this custom myself, I want to pass the savings on to you. So that's why I tell you to get a Gleason map. This is the accurate map of the world, and it allows you to start understanding all that type of stuff we were talking about. You can actually see the specific lines of latitude, longitude, look around and get a better understanding. Where is the Tropic of Capricorn and Cancer? How does the world look like in real life? So everyone should have a Gleason map hung up behind you. This North Polar AE projection map is the correct map of how the world really looks. I did a video recently where I explained how if you're up on top of the firmament looking down, this is what you would see. So this is why we base everything off of it, even the globe. You have to start with a Gleason map, see where the sun travels to for the seasons, and then that becomes your tilt. And the explanation for seasons on flat Earth is very, very simple. If the sun is up here traveling around, well, you're nowhere near here. It's going to be colder. That's how you get your winter. And consequently, if the sun is right over the United States, traveling around there, it's going to be hotter and you're going to have your summer. So seasons, like everything, makes perfect sense on the flat Earth model. So I hope this understood. I hope I could clarify a bunch of stuff.